Hey guys, John Adler. Let's talk speed cutting chain. Had some questions on, some ideas on modifying the basic saw chain to get that little extra out of it. And here's the way I'd like to approach it. Let's really quick review what that depth gauge does. All right, this guy up in the front. Depth gauge, raker, drag, rider, whatever you want to call it. Basically, we talk about it setting the thickness of the chip. Fair enough. But let's define what it does from a different angle. Let's talk about how the thickness of the chip, or the setting of this depth gauge, affects what we call the reactive forces off of the saw. Cutting downward on a log, right? Cutting with the bottom of your bar, that's going to be a pulling chain, pulls the saw away from you. Pushing chain is going to push it back at you. And then we've got that nasty, upper quarter of the bar tip, that's the kickback zone. So those reactive forces are affected a lot as far as how strong those forces are by how thick of a chip each tooth is trying to cut. With that said, let's throw some numbers out there just so we've got some sort of a baseline to reference from. Let's, for example, say we've got a 20-inch bar on our saw, and we're in the middle of a 20-inch in diameter log. Full bar, making contact, all those teeth, right, as it's traveling along, and I know they porpoise along, but you get the idea. We're in that point in the log where we're asking the engine from the saw to maximize that horsepower, but we got to keep that RPM up into that 10,000-ish RPM, right into that power curve. So the thickness of each chip being made by each one of those teeth affects how much power it's going to take from that engine. If the chips are too thick, it draws too much power, the RPMs drop, and we find ourselves lifting it up a little bit. If their chips are really thin, we can start leaning on the saw, trying to force it into the wood because we're trying to get it to cut even faster. Let's throw a number at this. New saw chain, right? 25 thousandths of an inch. Most chains, I know Oregon chain, they got a little 25 stamped right there. That's what it's telling us right out of the box, 25 thousandths. And most of us who work for a living in the woods with saws, we know that that's not thick enough. That's just where the factory sets it. It's kind of a rock and a hard place between a chain that can cut some, but the lawyers don't want the chain to be cutting too aggressive, somebody gets hurt with it. We file them down. So let's say that after we've set the chain to where we like to have it running, let's say the reactive pull of that saw when it's in the middle of that log, if say you could put like a fish scale on your handlebar, right, just to hold that saw back. Let's say that's generating 10 pounds of pull. Okay, so there's a number. We got 10 pounds. 10 pounds of pull there. Let's start modifying the chain. If at that, let's change this now. We're going to file that off a little bit, right? We take that down just a tad. So we're going into a 30 thousandths number. That's where we like it. But let's say we change now the cutter tooth itself from a round file to a square filed cutting edge. One of the cutting increases that you're going to see with a square ground chain is you actually take your top plate going from 25 to 30 degrees. That's your factory setting. You got the witness mark there on the bottom. That's, you keep the cutting edge there. But on a square file chain, that side plate is actually, if I can kind of illustrate by making a dotted line, thinking about looking underneath your top plate, the side cutting edge on a square file chain, you drop that back to 45 degrees. So you're taking a cutting edge that with a round file is 25 to 30 degree attack angle on the fiber to a 45 degree. So that's simply going to be sharper. It's going to cut that wood more easily. Same thing with your top plate. Instead of having that rounded effect from your round file, you flatten it out, chisel bit file. This is going to be sharper. With those two cutting edges, cutting the chip with a little less effort, let's say we could add 2 more thousandths to the chip thickness, but we don't change the 10 pounds of pull being generated by those teeth cutting that chip. I'm hoping you're staying with me now, right? Because this is where we're going to go. We got 2 more modifications we can do with this. So now we're at 32 thousandths instead of 30. The other thing that has been done, I picked up on this idea, is grinding the back of the top plates off. So on my other model I have, basically showing you the idea is to file that back end off. Now think about it, that part of the tooth is never really used, right? We never file back beyond that witness mark. I mean, if you do, you're really milking every bit of life out of the tooth. You know, typically you get about to that witness mark and your chain is shot. So this here, by taking that out, we're going to do 2 things. One, we're physically taking some weight out of the chain. It's minuscule, but it's something. Take that metal out of there. But more importantly, it's opening up the channel for the chip to slide out from under the tooth. That's where that chip goes. Contrary to popular belief, this is not a gullet. Okay, that gullet word comes from crosscut saws. Crosscut saws have true gullets. The real gullet to saw chain is the gap between the teeth. That's the void, right? That's the cavity, if you will, or gullet, where your chips collect. Yes, some end up in here, but that's not its job. It just happens to look round because of a round file. And if you look at the gullet on a crosscut saw, it's round, and thus that's where the name kind of got stuck to it. Taking that heel off, the chip is going to get out of there a little more easily. When that tooth porpoise is back, right? Remember that hooks the point, tips back a little bit. If we don't take that off, that little trap door gets closed a little bit. Grind it off, let that chip get out of there. With that little modification, let's add, say, I'm going to give that a 1. I'm going to add 1 thousandths more to the chip thickness. I don't think it's huge, but again, it's something. So now we're at 33 thousandths, and going back to the reactive force, that 10 pounds of pull hasn't changed. One more change we can do, and this is where I think we're going to get, more bang rather than just the bang for the buck off instead of just the heel. We got to remember the side cutting edge of the tooth. What's it doing? Cutting the fiber off. But remember, it's only that tiny little bit of side plate that's involved in cutting anything. That's your chip thickness. So from my fingernail down, all of this cutting edge doesn't cut anything. So you take out, now we've square filed the chain now, right? I know I have a round filed model, but you're with me in that we've square filed the tooth, we've cut the back off. Now this bottom, if you take that out by filing with a round file in the direction that you normally sharpen the tooth at, then we leave this whole side cutting edge with a sharp edge. No harm done, but let's think about what that sharp edge is doing. That tooth going through the kerf is going to create some drag, right? That sharp edge there it's rubbing, if you will, on the side of the cut. So that's creating some drag. That drag is pulling some power out of that engine. Instead of taking this out, filing from the normal filing angle, right, inside to outside, what I do, take the grinder, I use my round grinder, and I'll grind the side plate so that it's actually beveled. I'll try to show you beveled inward, reducing a lot of drag, because all of those teeth, both sides, all the way through the middle of that log, that side plate is rubbing on that curve. Let's bevel it in just a little bit. So we get rid of that metal, right? Reduce that drag, but don't dull the top of your top plate. That guy's still got to be sharp. That's cutting your wood. But the bottom, say bottom 3/4 of your tooth, that's not doing anything. Let's bevel it in, get rid of that drag. I think we could easily add another 2/1000 of an inch to our chip thickness and not increase that reactive force. Bottom line, we now have 35/1000 chip thickness, right? 25 is new, 30 is okay if you've got round file. Let's add another 5 with a square file and not get out of bounds as far as controlling the saw, making accurate cuts. I always like to remind folks when it comes to running a saw that there's 2 ways we can get hurt with a saw. We can have an injury or we can develop health problems. Injuries have a time stamp, right? I cut myself just after lunch. It was around 1 o'clock. So that's an injury with a time. Health problems. Health problems develop over time. And what we get talking about a lot with saws is back problems and carpal tunnel in the wrist, right? So if we're out of bounds on our chip thickness, we're kind of not really as careful with filing as we should be. We're kind of relying on the horsepower of the engine to get the work done rather than finesse with handling the saw. We can find ourselves what I call white knuckling a saw. So if this reactive force gets out of bounds, we actually find ourselves either holding on the saw tight because it's too aggressive, which again, we're tightening up the grip, or if it's not thick enough, chain isn't sharp, then we're forcing the saw. Same effect on the hand. That's where we're going to start to white knuckle those handlebars because we're trying to force a saw. It's a pretty narrow little window to get into where that saw cuts fast enough. I'm in a race, I'm trying to cut wood, and at the same time keeping that saw so that I can relax with good body mechanics, a little finesse with the saw, let the saw do the work, and I'm not death gripping the handlebar all the time. Now, I do want to comment on why I don't think doing the healing is a term I've heard, cutting the heel off on your chain if you're round filing. The problem that's going to happen is if you can picture here, by cutting the back of this off, hoping you can see that. So that's what we're doing to the chain. Now, if you round file, let's say we're round filing, right? We're coming back here and coming back here. What's going to happen is this area right here is going to get so weak. I think you could see it better. We actually take that right out of there. So there's what would be left of the tooth if we've round filed. What happens here is back on the side plate, this area of your side plate is going to become so weak that your top plates will start snapping off. So that's not good. So not that it can't be done, but just a heads up that square ground you don't have that hollowing out back under the top plate. Square 5, you've got that straight edge 5 degrees forward. Now that's what I do with my chain. I find that I get that little extra cutting speed. We're not talking about taking a chain that doesn't cut to one that cuts like crazy. I'm just working with the idea of a chain that cuts really well and getting it to cut really, really well. That little extra. Now, I do want to talk about the difference between what I'm doing and a competition chain. Competition chain, they'll do another, there's actually a couple more modifications, but the important one I want to talk about and mention is don't mess with the depth gauge. What they'll do is they'll actually thin the depth gauge, narrow it up. It's the same idea. They're trying to reduce that drag. But remember, I'm doing this on a saw that I'm working with in the real world. I'm out on the ground, right, climbing through the brush, and you know the deal. So I don't want to compromise a safety feature of the chain so that I can make it cut like crazy fast. Competition chain is just that. A nice flat mowed field, log sitting in a sawhorse, nice and secure, and you just gotta rip through that thing as fast as possible. That's a lot of fun, go for it, but don't change your depth gauges as far as shapes and so on with thinking that's gonna get you anything out in the real world. It makes the saw chain in the saw more dangerous to extreme kickback. So there's a lot of different designs and depth gauges. You know, this is your basic old style. I've got the model here. You've probably seen some of this chain. You know, it's a Vanguard style. There's the double depth gauges and ramped depth gauges. All of that is in a design to reduce the power, right, of a kickback. The chain manufacturer, their company lawyers, are just deathly afraid of a lawsuit coming from a kickback caused by their product. So they're trying to do some of these features to reduce the potential of a bad kickback. There is no anti-kickback chain. Doesn't exist. Okay, any chain can. But just wanted to mention that. That's one of the biggest differences between what I'm doing with just trying to get that extra speed out of a chain without crossing the line into a true competition chain where things can get dangerous out in the real world. So, happy to answer any questions. If that helps. Hey, like I've got on the sign there, if you like this stuff, give it a thumbs up, subscribe, you know the gig. So, be safe out there.